Geometric series can be used to express repeating decimals as fractions. Recall that a geometric series is given by a plus a times r plus a times r squared plus a times r cubed, and so on, adding each term together, where r is the common ratio between consecutive terms. If it is the case that the absolute value of r is less than 1, the series converges to a over 1 minus r. Otherwise, it diverges. To convert from repeating decimals to fractions, we must first identify a and r. Let's try an example. We want to express the decimal 0.259 repeating as a fraction. First, rewrite the repeating decimal as a sum of decimals so that the sum adds to the original decimal. This gives us 0.259259259, etc., equals 0.259 plus 0.000259 plus 0.00000259, and so on, following this pattern. Factor out a common term. In this case, we can factor out 0.259. This gives us 0.259 plus 0.259 times 0.001 plus 0.259 times 0.000001, and so on. Examine the result and note that every term has a factor of 0.259 and the remaining factor is a factor of 0.001. So, we have 0.259 times 1 plus 0.259 times 0.001 plus 0.259 times 0.001 squared, etc. Recalling our geometric series, we see that a is 0.259 and r is 0.001. Since the absolute value of r is less than 1, we can replace this geometric series with its sum, which will be a over 1 minus r. Now we know that 0.259 equals a over 1 minus r because the absolute value of r is less than 1. Recall from before that this is equal to 0.259 over 1 minus 0.001. Therefore, 0.259 repeating equals 0.259 over 1 minus 0.001. Rewrite the decimals as fractions. So we have 259 over 1,000 times 1,000 over 999. This equals 259 over 999. We can reduce this fraction by a factor of 37, since 37 is a factor of both 259 and 999. This gives us 7 over 27. Therefore, 0.259 repeating, written as a fraction, is 7 over 27.